And welcome to today's webinar. My name is Benjamin Taylor, and I'm here with Daniel Leong, and we are both content engineers with Markforged. Today we'll be taking an inside look at how to produce 3D printed metal parts with the Markforged system. On the agenda first is an introduction to Markforged, after which we will jump right in to an overview of the atom process, after which we will step through each part of the process. So we'll talk about printing, washing, drying, and then sintering, after which we'll address any questions. First, a little bit about Markforged. We are the only 3D printer company that provides a complete solution for industrial 3D printing. We provide software, printers, and materials that allow you to print everything from lightweight, high-strength composite parts to dense metal parts, which is what we're talking about today. The way we produce metal parts is with a technology known as ADAM, Atomic Diffused Additive Manufacturing. This is just a hybrid of metal injection molding and 3D printing. It all starts with your design. Inside your CAD software, you can design a 3D part and export an STL file. You bring that into our software and send it to the printer. The printer creates your part using a material that is a combination of a metal powder and a binder. That binder is what allows the metal powder to stay in place as it travels through a post-processing system. That post-processing is there to remove the binder and allow the metal powder to densify, and when it's done you get a solid metal part out that you can treat just like you would any other metal part. The first thing I want to address is scaling. The size of the part that you design in your CAD software is captured by the STL file that you export. You bring that into Eiger, and Eiger automatically scales it up by about 20%. That scaling is to compensate for the shrinkage of the part that occurs during the post-processing. So the part that you get out at the end of the atom process is the same size as the part that you put in to Eiger to start with. So let's go ahead and take a look at the printer settings that are available in Eiger. First thing is the material. By selecting a metal from the materials dropdown, you are telling Eiger that you want to use the metal system, which gives you a couple options under printer settings. First is your original units. This just needs to match however you exported your file from CAD. This can either be imperial or metric units. Next is the scale. Notice on the bottom left, Eiger is telling us that the part that we're seeing on the screen has been scaled up to compensate for the post-processing. If you would like to further scale your part, you have the option there on the right side of the screen. If you would like your final part to be a little bit smaller than the CAD model, you can bump that number down. If you'd like the number to be a little bit bigger, you could bump that number up. Next thing is cloud slicing. This is an option that you can use if you're having some trouble slicing due to network connections, and it'll slice it locally on your computer. Last, I'd like to point out the part detail that is shown on the left side of the screen. That will give you things like wash time, print time, and material cost. So this is an option that is available to you even if you don't own a Metal X. You can upload your parts and slice them for metal, so you can get a cost of just how cheap you can produce metal parts, as well as get a grasp on about how long it's going to take for those parts to print and wash. So once you click print, that part will be sent over to the printer, and as you can see here in this time lapse, the printer is doing three main things. First, it's producing the part that we just told it we wanted. Second, it is producing a support structure. This structure is made out of the native material, just like the part is. And thirdly, there is a white layer in between the support structure and the part. This layer is there to make sure that during the post-processing, the support structure doesn't adhere to the part, and you can just remove those supports by hand. So removing your green part from the printer is very easy. First, you just open the door, as you can see here, and then you will remove the part, which is on a print sheet. This print sheet is just a thin piece of plastic, and you can easily peel your part off of the plastic, as you can see in the video here. That print sheet can then be recycled, and you have your green part. And now our part is ready to go through the post-processing system, all of which is managed through Eiger. Once your part is done printing, it'll show up here in the wash utility under ready to wash. All you do is find the part, select it, and then hit wash selected. The wash is a solvent bath that breaks down the binder that is holding the metal powders in place, and that is a function of time. So Eiger gives us a wash time, so we know how long it needs to be in the wash, but of course Eiger will send you email notifications to let you know when you need to do that. Now that we've told Eiger we're going to wash a part, let's see how to put a part in the wash. The first thing you want to do is open the lid to the wash and slowly raise the basket out of the solvent bath, and then hang the basket from the lid of the washer and let it drip dry for about 10 minutes. This drip dry and the slow raise and lower of the basket is there to preserve the solvent, to keep it in the bath and prevent it from evaporating. After the drip dry, you can completely remove the basket from the washing station and place your part in the basket. As you can see here, the washing station is a batch process, so you can wash multiple parts at the same time. You just need to be sure and leave enough space around parts so that the solvent has good contact and can dissolve that binder. Once the basket is full with your parts, you can lower it down into the washer, and again, doing so slowly helps conserve your solvent. And then you can close the lid. After our parts have washed, it is time to remove them and let them dry. The process is the same here. Just slowly raise the basket out of the solvent, let it hang in a drip dry for about 10 minutes to allow that solvent to condense and go back into the solvent bath. So you can see here, you just remove the basket and then place your part on the top of the wash and slowly lower that basket back into the solvent bath and close the lid so your parts can continue to wash. The other side of the washing station is a dryer. Just place your part in the dryer and close the lid. The parts will sit in the dryer for about 1 to 2 hours. This is to allow the solvent that's in the part to evaporate before we send it over to the sintering. Now that our part is dry, we can go ahead and load it into the sintering furnace. The first thing we're going to do is place the part onto what's called a stage. That's just a ceramic plate to hold the part during printing. Open the furnace door, slide that stage into place, making sure that it's in the central portion of the furnace and also that it's level. Once everything's in place, we seal up the furnace door with these 3 cap screws you see here. After which we will go around to the front of the machine where you'll see the LCD screen. Here on the screen we'll just select Start Furnace, and when you start the furnace, that is telling Eiger that you are now sintering these parts. Just like the washing, the sintering process is monitored by Eiger. Here you'll see the center overview portion of Eiger, and the most important part is the progress bars. The progress bar is divided into 3 parts. First is the orange portion, which is the debinding stage. This is when the furnace is heating the part and burning out what is left of the binder. After which it goes into the red portion, which is the center profile. This is going to heat that metal up even higher and make those metal powders actually densify together through the process of sintering. After which it enters into the blue portion of the progress bar, which is cool down. After cool down is complete, you'll receive an email notification letting you know that your sinter run is now over and your parts are ready to remove. To remove your parts from the furnace, just unseal the door with those 3 button head cap screws, swing the door open, you reach in, grab that stage, and carefully slide it out of the oven. Place that stage on the bench top and you can remove your part from the stage. At this point, the support structure can easily be removed from the part because that ceramic layer has now become powder and there's nothing keeping the 2 parts together. And here we have our finished part. At this point, the binder has been completely removed and we are left with solid metal. That part can now go on to receive any additional post-processing that the application may require. So it can be heat treated or milled or powder coated, just like you would treat any other part made from that metal. Most importantly, that part is now ready for use. It is so exciting to see how you can take a part from a 3D model all the way through to a solid metal part with the Markforged system. So at this point, let's move on and see if we have any questions.